Okay, so for today's AP review, we're going to talk about limits. Do you remember anything about limits? Like anything at all?
Yeah.
Qdoba. Okay, that's good. I'm going to talk about that. Okay, what about continuity? Anything about continuity? Yeah, no holes. Okay, so we're going to compound, get more. What about differentiability? What really differentiate? What really word are they talking about there? Derivatives. Okay, so these three ideas are closely related, although they are not the exact same, but they're related. Okay, we got to keep them straight, and that's kind of what I'm going to make sure you understand which one's which, and just remind you of a few things. So, about continuity. A function is continuous if it has no holes or jumps or vertical asymptotes. Okay, that's all important. Some of you might think, oh, I can trace it with my pencil without picking my pencil up. However, there is something called the definition of continuity, and that's what this is right here. Okay, on the AP test, on your mock exam even, you were asked to, was something continuous, use the definition of continuity to explain your answer. Okay, what that means is you have to refer to these three things. Okay, so, and it doesn't necessarily have to go in this order, like 1 and 2, typically we have the limit first, and so it doesn't really matter. But F of A exists means, like in our situation, if we're going to meet for lunch at Qdoba, Qdoba has to exist. It can't, like, not be a real restaurant in the real world, okay? And so we also call this the point. The point has to exist. Okay, so if I have an A, then I have to have a point there. Okay. Secondly, the limit has to exist. More specifically, the left and right-sided limits have to be the same. Okay? So as we're coming to the left and as we're coming to the right, it has to converge on the same point. Okay? That's you and me agreeing to meet at the same Qdoba. Okay? And then, and that's all it takes to really have a limit existing, is the left and right-sided limits have to be the same. Okay, but for something to be continuous, the last thing is where we meet has to be the same as the point. So imagine this. You and I decided to meet at Qdoba. We show up at where we thought Qdoba was, but we forgot or didn't know that it burned down and it moved down the street. We still met. The limit exists, but we're not meeting at the right place. That would not be continuity. So continuity does mean no holes, no jumps, all that good stuff. But in terms of the definition of continuity, we have to do this. Okay? I'm going to do this a little bit differently with y'all than I did with my other classes today. I want you to go ahead and go to your last page. Sorry, I forgot I had some other stuff here. So this would be number 26. So if you just flip your packet over to the very back, here is number 26. All right. I want you to read this problem. And I want you to think, does this sound familiar? Have I seen this problem before? Where did you see this problem? It was on the mock exam. You would have seen this on Friday unless you weren't here.
I wasn't here.
All right, and some of you saw it on Thursday because you had that part then. All right, now this is a free response question, so we got to think, we got to earn the points. We can't just be satisfied with our answer. We have to give the AP grader the answer they want it, how they want it. So for part C, you were asked, okay, given this new function g and its piecewise, is g continuous at x equals -3? Okay. When you see the phrase, use the definition of continuity, you need to go ahead, my suggestion, and write down a 1, 2, and 3. Okay, that's going to remind you that you have to show 3 things. It's okay if you don't write the numbers down. This is just a strategy we're using to make sure we don't forget anything. Okay, so you can show that the point exists or the limit exists first. It doesn't matter. I want to go ahead and show that the limit exists first. Because sometimes when the answer is no, that's the easiest thing to disprove, and then we could stop, actually. And so in a piecewise function, to prove that the limit as x approaches -3 exists, what I really need to do is to find the left and right-sided limits and show that they're the same. Okay, so this is how you would write a left-sided limit. On our piecewise function, which piece is the left side? Think about, this would be for values that are less than -3, so we're going to use the top. So I'm going to say f of x, or specifically in our problem, f of -3, because that's what you do for limits. You plug in the number, and for x. All right, that means we got to go back up here. Okay, so square root of 25 minus -3 squared. Let me extend that. Okay, you should be able to do this without a calculator, and you do have to simplify here because we're going to have to show if this is equal or not equal to another number. And so we do have to simplify for that reason. So this would be 25 minus +9, or 16, and so square root of 16 would be 4. Okay, we've just found the left-sided limit. What do we need to do now? We need to find the right-sided limit. And if they're the same, we're on the right track. If they're not, then this thing's not continuous. Okay, so I'm going to do the same thing, but instead of a minus, I'm going to write a little plus right here. This is how you write a right-sided limit. And so which piece of this piecewise function is the right side of -3? The x plus 7. So again, with limits, you just plug the number that you're doing the limit of in for x. And I also get 4. We have just proven that the limit as x approaches -3 exists. Okay, it exists, and it equals 4. We don't have to really write that it equals 4. We kind of already showed that, but you have to show that it does exist. You have to write something here so that they know you've checked that box off. All right, you got a point, by the way, on this just for showing that you even knew one-sided limits was something you had to do. That got you a point on this problem. All right, so for 2, we have to find the actual point, which we've kind of already done. All right, but we can't say, hey, we already did that. I don't need to show anything else. No, you still need to show it. You don't want the AP grader thinking that you're like BSing your way through the problem. Okay, if you have no idea what you're doing, that's your only choice. But when you know what you're doing, you got to show that you know it. So you got to actually write g of -3, which is the same thing. You see this equal to right there? That tells me that that's how you find g of -3. Okay, so I'm going to go ahead and write that that's f of -3. You could go ahead and write that right there. What I've written here is fine. I've already shown the calculation, but it shows that I know what I'm doing. Okay, and you could definitely show more. Okay, so that thing exists too. So that's good. Right? The limit has to exist, the point has to exist, and then I'm going to move this up just a little bit. Finally, they have to be the same. Are they the same? Yes. The limit as x approaches -3 of g of x is the same as g of -3. Okay, these are the 3 things that they're looking for when they say use the definition of continuity. Finally, we have to actually write our answer. We kind of got used to writing therefore at the beginning of the year. You could write so, you could write and, you could not even write a word, but you got to say something about like actually answering the question. G of x is continuous at x equals -3, and you got to say at x equals -3. We have only proven that g is continuous at this x value, not at any other x value. Okay, so like I said, you got a point just for doing one-sided limits, and then you got a point if you got everything else, including the right answer. Okay, so that was 2 points. If I gave you a problem like this right now, all of you would probably do better than you did when we did the mock exam. I found out when we did the mock exam that you guys do kind of understand this, but you don't, all the details of it, that wasn't there. Okay, and that's why we review. Okay, So I want you to go back now to the first page. I know I'm kind of jumping around here, but I wanted, since I was talking about that definition of continuity, I wanted to go ahead and do that example instead of waiting. All right, so we have this idea of limits. We have this idea of continuity. Now let's talk about differentiability, okay? That just means, can you take the derivative at all the points or at an individual point, depending on what they're asking, okay? Differentiability does imply continuity. So if I say this function is differentiable, you know it has to be continuous. You don't even have to prove it using what we just did. You could just, that's just given. All right? But you could have a continuous graph that is not differentiable. It doesn't go both ways. So if you look at this, this is a calculator screenshot of a absolute value equation. Okay, so look at this equation, or this graph, sorry. This is continuous. All right, I can look at it and know for sure that it is. If you were asked to prove it, you would have to go through the 3 steps. Is the left and right side limit the same? Yes. That as x approaches 3 from the left and the right, the y value is 0. The point is also located at 0, therefore they're equal and you have continuity. Okay, all that's great. Okay, this thing though is not differentiable. Do you remember what we call points like this? We call that a cusp. Okay, it's a sharp turn. Okay, it is, you're going one direction and then boom, you don't even have, there's no gradual change, it's just a stark change to a totally different direction. Okay, and so there's some stuff down here, and this, what I'm going to do is I'm going to write this maybe in a more friendly way. So if you were asked to show why this is not differentiable, saying it's a cusp is maybe okay, but it's not really mathematically, it's kind of like saying, because you could trace it without picking your pencil up, okay? What we could do here is use the idea of left and right-sided limits again. So look at what I'm going to write here. This is going to help you on some of your practice problems. I'm going to take the left-sided limit, not of f of x, because that would be for continuity, but for f prime of x. What this would really be saying is, what is the slope of this function as x approaches 3 from the left? You can't do this, by the way, on anything, but I can do it here because this is a line. So what is the slope on the left side? And you can maybe look at your calculator to see the rise over run. It'd be -1. Absolute value is broken up into a -1 slope and a +1 slope, unless there was like a stretch or compression or something. Okay, so it's not that the left-sided limit is -1. It's that the left-sided limit of the derivative. You could almost call it like the left-sided slope. That's -1. What would be the right-sided limit of the derivative be? What's the slope on the right side? +1. Okay, these two things are not equal. That's how you could, be more specific in free response answers showing why this is not differentiable. Okay, that's not going to be required a whole lot of the time. Most of the time, these things tend to be multiple choice. Okay, let's turn the page and let's look at another situation. Okay, this graph is going along. It gets vertical for a split second and then it goes along again. Is this thing continuous?
Yes.
It is. You can trace it without picking your pencil up. If we needed to use the definition of continuity to prove that, we could. I already did that once. I'm not going to do it on this problem. This is another example, though, that is not differentiable. Okay. So, again, they kind of have this, it's very formal here. Something that I think is a little bit more our style is to go ahead and just find the derivative. Find the derivative using the power rule. So that would be 1/3 times 2. That's 2/3. X, what would be the new power? -2/3. Hey, what does a negative exponent do?
Pushes the x to the bottom.
That's right. And so here's our problem. What is f prime of 0?
0.
undefined. That's because it's basically infinity when you talk about a limit, which is also undefined. Okay, think about this. A vertical line. What is its slope? Undefined. Or you could say a vertical line has like an infinite slope. It's the steepest anything could get. I mean, the two ideas are very closely related, okay? But that's why this thing is not differentiable. Okay, let's check for understanding here. All right, what we're going to do is I'm going to do the first one with you guys, and I'm going to have you guys do 2 and 3. So sketch a function with the property that f of a exists, but the limit does not exist. Okay, so I'm going to draw this. I'm going to put an a there, and it says f of a exists. So go ahead and draw a point. The point's there. It exists. But how would I say that the limit does not exist? Excuse me. And remember, limits like you and I meeting for Qdoba. I could meet at the Qdoba. And what could you do? You could go be at a different one. This is called a jump, a discontinuity, by the way. You don't have to know that phrase, but that's what it's called. Okay, so I want you to draw a picture for 2 and 3. And the whole idea here, by the way, is that this stuff sounds familiar. You don't have to have remembered everything, but it's like, okay, I'm getting this better than I did before. If this all sounds super foreign to you, that's when you need to come in for tutoring. Because I'm not going over every little thing. And I know I'm going fast. Here are my pictures. Yours look exactly like mine? Probably not. That's okay. There's so many different things you could draw, but on 2, you needed to have this idea of the 2 sides come together to meet at a hole. That's what you had to have there. The limit does exist there, but the point is not there. Okay? Number 3, it's kind of the same thing as 2, except there's a point, it's just somewhere else. Okay? It could be above, it could be below. That part's not a big deal. All right, let's turn the page, and what I want to do is there's just a couple of things I haven't talked about that I want to give you a heads up on before you start practicing. Okay, for just your standard limit, just some standard limit, remember you're plugging in the number, okay? If you, after plugging in the number, if you get 0 over some number, what does that equal? Like, when I say a number, I mean not 0. Like 0 over 2. What does that equal? 0. Okay, so that's totally fine. And if you got like 2 over 3, then 2/3 is your answer. Okay, what if you get a number divided by 0? And again, a non-zero number divided by 0. This thing is undefined. This is caused by a vertical asymptote. This is starting to get into infinity. Okay, infinity doesn't exist really. I mean, you know what I mean? Saying it's a whole does not exist situation. A one-sided limit though could equal positive or negative infinity. But if you wrote undefined or does not exist, you would be fine. It's not typically asked that way anyway. It's usually asked by doing multiple choice. And they're not going to have infinity and does not exist as an answer, both as answers. It's not going to happen. Okay. What happens if you get 0 over 0? Or what happens if you get infinity over infinity? This is a situation where we don't know. We don't know if it's 0. We don't know if it's 1. We don't know if it doesn't exist. This is called indeterminate form. This is when you want to use L'Hopital's rule. Okay, L'Hopital's rule is technically a BC topic, meaning you shouldn't have to use it on your exam, but it makes so many problems way easier, in my opinion. If you plug in the number and you get 0 over 0 and infinity over infinity, let's talk about what L'Hopital's rule is. If this happens, what you can do is rewrite it as f prime of x over g prime of x. In other words, take the derivative of the top, take the derivative of the bottom, and plug it in. What if you still get 0 over 0? You do it again, and again, and again, and again, okay? Okay, you can only use L'Hopital's rule on 0 over 0, and infinity over infinity. Nowhere else can you use L'Hopital's rule, okay? Some students overuse it. Okay, one more limit thing that we haven't talked about is, what if we're taking a limit as x approaches infinity? This is like numbers 1 and 2, if you look right on the next page. Do you remember how to do these? This is where you're basically following your horizontal asymptote rules, okay, which I showed you guys as Bobo, Bot, and Betsy. If bigger on bottom, it's equal to 0, meaning the degree is bigger on bottom. If the degree is bigger on top, okay, then that would be infinity, okay? There'd be no horizontal asymptote. If bottom equals top, Betsy, then you use the coefficients. Okay, you could also use L'Hopital's rule, though, on these problems, if you needed to. All right, and the very last thing I want to talk about is the definition of derivative. And I'm going to talk more about this tomorrow, but I want to at least say a little bit of it right now. So f prime of x is equal to, by definition, the limit as h approaches 0 of f of x plus h minus f of x all over h. Does this look familiar to you at all? It should. It's been on a lot of the after parties this year. A lot of them. Okay, your big indicator that you can, if you get a limit and its limit as h approaches 0, you got to think, hey, this problem is going to be way easier if I just do a derivative. Because you guys are really good at derivatives. Some limit problems, though, are really hard. So I want to do one of these with you, okay? I want you to turn to number 5. And so if you look at number 5, what's telling you that this is the definition of a derivative? It doesn't say derivative. I don't see f prime. I don't see dy over dx. The formula, see that limit as h approaches 0? What this means is all I really need to do is figure out what f of x is and then take the derivative. That's all I need to do. This is considerably easier than trying to solve this as a limit. If you want to solve this as a limit, you're going to have to start using trig identities, trig proof type stuff. All right? So the f of x is always right there after the minus. So here my f of x is tan 3x. Now this could be more complicated if there was, instead of an x, a number. In which case, you're going to have to pretend there's an x, take the derivative, then plug the number in. And you'll get to practice that one. And we've seen those before as well, but that's not happening here. So what's the derivative of tan 3x? Yeah. I'm going to go ahead and write it how most people would probably write it, which is secant squared 3x times 3. Of course, the 3 would go to the front, and you would get b. This problem as a derivative, lots easier than as a limit. Okay, and so you got to recognize that this is definition of the derivative. Okay, the only other thing I would like to do now is to look at our ultimate study guide and say, hey, whoops, did not mean to do that, really. Oh, why is this happening? There we go. Okay, good. I would like to go through and write down anything that we have talked about. Okay, so I'm going to start in this column over here. So limits. Limit from the left of f of x as x approaches a. I'm going to change to red here. And this is all stuff that you can do. You can write more down, you can write less down. This is for you to study, so write down the stuff you need to study. Okay, limit from the right. It would be the limit as x approaches a with a plus there of f of x. And remember, for the limit to exist, these two things have to be equal to each other. Okay, so a situation where a limit fails to exist, the easiest one that I can think of is when the left-sided limit, this is when you kind of have to start writing small, it does not equal the limit as x approaches a from the right of f of x. This would be like a jump discontinuity. We're meeting at two different places. Anybody think of another situation where the limit doesn't exist? So a cusp isn't an issue. That's going to be for differentiability. A hole, a limit could exist at a hole. We could meet at a Qdoba that has totally blown up and left a hole in the ground. We could meet there, right? And I know I keep going back to that, but that's because I want y'all to really internalize it. I feel like somebody said it.
Point A doesn't exist.
So that's continuity. But this is why we're going over it. I'm going to start writing it, and I want you to shout it out when you think you know.
Vertical asymptote.
A vertical asymptote. Because at a vertical asymptote, you can never cross over a vertical asymptote. There's no meeting. Okay? This kind of falls under the fact that the left and side limits don't approach, but it's for a different reason. And then the last one, I'm sure you don't remember because so far today no one has. Yeah, y'all remember this one?
I remember the word, but I don't remember it.
This would be like in a trig graph. I'm going to draw it right here, but then I'm going to erase.
Oh,
it's like,
so it's like,
and then it goes,
yeah.
like, okay, there's nothing happening there. Okay, this is rare. It's really not even usually on the AP test, but it could be, okay? L'Hopital's rule. Okay, right here we should probably write something about that if the limit as x approaches a of f of x over g of x, if this thing equals 0 over 0 or infinity over infinity, we need to rewrite it as the limit as x approaches a of f prime of x over g of x. And of course, you could write more here if you wanted to. This is for you. I know I'm repeating myself a lot, but I just want to make sure you don't have to copy down exactly what I write. Okay, definition of continuity. We talked about this. The limit as x approaches a of f of x, that has to exist. What does that imply? If the limit exists, about the one-sided limits. The left-sided limit and the right-sided limit, they have to be equal. You may want to write that down because that's not going to apply to, it's going to apply on the piecewise problems. It may not apply to every problem, but the limit has to exist. The point has to exist. F of A has to exist. And so you don't have to write the word exist when you're proving this, but you got to show somehow that it does. And then the last thing was they have to be equal to each other. Okay, is there anything else that we can write down? I hate to scroll up because some of you look in that second column, maybe towards the top, and see, is there anything else that we could write down? We can do definition of the derivative. It is the limit. I'm going to write it below here. Sorry. It's the limit as h approaches 0 of f of x plus h minus f of x all over h. And then situation where the derivatives fail to exist. Okay, one that's easy to overlook is if the thing is not continuous. If the function is not continuous, the derivative doesn't exist. You have to have continuity to have differentiability. But do you remember the other two situations? Look back on the first page of your notes if you need to. A cusp. We have continuity at a cusp, but no derivative. And what else? What was the other one? A vertical tangent, which is more rare. So I'm trying to kind of write these in order of when you see them. And if you wanted to draw a picture on either of those, you should do that. Okay, your homework is to finish this packet. You have about 10 minutes left. I would look through it, and if there are some that you're like, I don't know how to do this, I would do those first so you can ask questions. This is due tomorrow. The